Well, this lecture talks about probably one of the most important topics in Bayesian estimation and Bayesian statistics in general, because this topic provides the workhorse, covers the workhorse of Bayesian estimation. So recall that the posterior probability density of posterior probability distribution of this parameter theta given data d is proportional. So this is sign is called proportional. Proportionality sign is proportional to the probability or the likelihood of data given theta. This is simply likelihood and the prior, okay, the parameter or the parameter vector of our interest. Here, why we say it is proportional? Because we omit a denominator here. If you recall the Bayes theorem, we should have had the probability of observing data, the P of D in the denominator. If we have that term in the denominator here, then it is not proportional. Instead, we should say equal. But we drop that term as a normalizing scaling factor. Then we say the posterior is proportional to the product of likelihood and prior. Okay, so since P of D, that is the probability of observing the data, can be viewed as a constant because it does not involve the parameter theta here. So not involving theta, our objective becomes the product of likelihood and prior. Is to simulate this product. So just to refresh, P of theta, it's called prior probability density function of prior probability. Right? P of D given theta is likelihood. And P of theta given D is called the posterior probability distribution. And sometimes in some textbooks, they use lowercase p to denote that, to mean that, this is not really a probability, okay? For example, this one is likelihood, this one is prior probability density, okay? So once the product P of D given theta and P of theta can be estimated, simulated, then the posterior, okay, that is given the data, probability density of theta can be obtained. Since P of D here is a constant, roughly speaking, is a normalizing scaling factor. Okay, so after the simulation, what do we get? Or what really do Bayesians want after, we simulate the posterior? Well, of course, it's the posterior itself, right? And more importantly, is summary statistics of or other quantities of interest related to the posterior, like the mean of the posterior, median of the posterior, by 2.5 percentile to 97.5 percentile, right? The standard deviation, etc. Describe the posterior distribution of the parameter. Okay,